morning, good afternoon, good evening, wherever you are joining. This is Startup School. This is Timon, go-to-market manager at Google for startups, bringing Startup School Gen AI to you. I'm super happy to have you all here. Again, I see hundreds of joining. I'm super happy for that because we have a very important and interesting topic today. We're going to talk a little bit more about code generation, code completion, code chat, everything related to generative AI. We are almost halfway through Startup School Gen AI. Can you believe it? It's been third week. Amazing stuff. Before we go directly to our instructor and today's class, most of you should know the drill. Couple of information before we start, especially for those that are here for the first time. So quick reminder, our structure, we are seeing each other for live sessions such as this one. You're probably joining this live. Maybe you're watching this on demand. It will be possible. We are recommending as a kind of a homework to do some of labs or do some of the notebooks. Today, we will be practicing using notebook. Notebooks, as you might be already aware, are not available in Skills Boost platform. You will need your own cloud environment to run a notebook. More instructions about how to run a notebook is available in this link that you should be all familiar with, Gen AI Labs. Couple of housekeeping rules for those of you that are here for the first time, mostly. Please use the QA function. We are very happy when we see literally hundreds of questions from you. It's below me, somewhere there. There is a summary and QA button. When you click QA, you will be able to post your question. We are moderating the questions though, so don't worry if it doesn't show up just automatically. We're making sure that the best, inclusive, and the most interesting questions are being posted. We have AI experts at hand right now that will answer all of your questions. But the most common one, the most upvoted, we will discuss them with our instructor at the end of today's class. This class is recorded. We are not sharing slides, but this recording is available for you on the very same page you are seeing it right now at the end of the day today. So it's in about 8 or 10 hours when our Americas class is ended. The labs and the notebooks that we are recommending and we are covering, well, they are not obligatory per se, but we are recommending to practice what you have seen here after the class is finished. So don't try to set up your accounts right now, access Skill Boost. Now just focus on your questions, focus on what the instructor will show you. That's, I think, the most important. The rest will wait for you after the class. If you have any questions, if you encounter any bugs, please email me or my friend Luisa that is hosting the evening classes at startupschool@google.com. And with that, I think this is all that is left for me is to invite my fantastic speaker for today. We're going to have Lavi Nigam calling from India, a fantastic developer advocate. He was just recently presenting a lot of similar topics in Japan, where a lot of our developer advocates met for a webinar. Sorry, not webinar, but a live training on Gen AI. And today, Lavi is going to focus on code generation, code completion. So all of you developers that are working with the code, this is the class that you cannot miss. Lavi, floor is yours. I see you, well, in about an hour for the questions and answers.
Thank you, Damon. Thank you so much for introducing, and thank you, Aga, for managing all of this. It's not going to be possible if I were to do this. But good morning, good evening, and I don't know, maybe good afternoon for some of you if you're joining in from India. And as Damon mentioned, I'm developer relation engineer. I have a background in ML engineering, and that's the kind of thing I do here. But in today's session, the focus is that we are going to talk about how do we elevate the developer productivity with Google Cloud. Now, when we sort of go through this, and there's going to be a lot of different things that we'll cover today, but essentially at the high level, the kind of things that you will experience starts with code generation, completion, chat, function calling, using both the Google Palm as well as the Gemini model. Now, one thing to keep in mind is that this is going to be a lot of hands-on, hands-on in a sense that we'll go through codes and everything. You may or may not be able to sort of do with me, like Timon was saying, but the session sort of focuses more on the hands-on part of things, which is like you will see how to do these things rather than going through the presentation. So I will cover presentation, but I'm not going to sort of stress too much or spend too much time, because I'm sure all of you are smart enough to figure out why do we need all of these things. But we'll spend more time in the notebooks. um, the other thing is, which is important, is there are some there's a distinction between some of these features. So the things that we'll see, some of them are available as Palm models and they are yet to graduate to Gemini. And there are some functionalities like function calling, which is very important from a developer point of view, which will happen in the Gemini by default. So I'll let you know when those features are being walked through, that they support as of now which particular model. So it's very important for us to do that, right? Okay, without sort of wasting much time, what I'm going to do is I'm going to start with the very basic presentation that I have, just to sort of cover the basic premise of what we are trying to do, and why you should be focusing on increasing the developer productivity. Now, one thing, and before we go sort of jump into it, is to understand that and again, I'm assuming that all of you sort of understand, because you've taken a lot of sessions now, and most of my colleagues would have introduced you to what LLMs are, what are different offerings of Google in terms of models, in terms of ecosystem, in terms of products. So you're pretty aware of all of those things, I'm assuming. If not, maybe this there might be some things which you may not sort of understand. But essentially, the goal here is that we have seen the power of LLMs. We have seen that LLMs can do lot many things, and we have played with them with small sort of use cases where if you want them to write a program or a code in a different language, it helps you do that, right, very effectively. So that's pretty much where the genesis of this whole productivity of developers comes into picture. That if to, let's say, a tool like Bard or ChatGPT, when you go and do a simple prompt saying, hey, write me a Python program that can do this and this, the genesis of that whole premise sort of comes very realistic, because then you're like, hey, if I can do this one on one, I can sort of think about this from more day-to-day developer work as well, right? Because there's many things a developer does, right? So again, please do not think of this as, oh, this will happen and our jobs will be lost. This is not the session is not talking about that. The session is not about automating everything that a developer does. It is, again, like the session name was, it is elevating the productivity. So it is helping you do more, is as simple as that. So again, we'll not sort of think more about, oh, this, what if LLMs will do everything, will software engineers have job and all. That's not what we are discussing, right? So things like, how do you generate good blocks of code which are part of your overall architecture? And we all know, right, like we have all done coding, so it's not just that 100 lines of code is the overall code that you have in your application. There's thousands and thousands lines of code. When we ask the any LLMs to generate something, those are certain blocks inside those architectures, the big architectures that you're developing. So the basic elements of the productivity, which we'll also see from a hands-on perspective, that how do you sort of do these basic things. So for example, the generation of a code, given a problem statement, can an algorithm generate something like it in different languages? So you give a problem statement and then it should have a capacity to generate the code to solve that particular problem statement. The code refactoring, how do you refactor the code? The completion part, how do you sort of, you're writing something and you want the codes to be completed, the explanations of the code. Again, a lot of time we are working on a code base which is either written by our colleagues or maybe some other team, and you may want to sort of understand what's going on, and you may want an assistant which can help you do this quickly, right? I mean, you can always rely on humans to do that, but again, we know that teams have their own bandwidth, they may or may not have free time, and they may or may not be good at explaining how they have done whatever genius they have done, right? So Code explanation is also very interesting use case that comes out of that. The documentation, we all hate writing big documentations. It's a most important aspect, but again, it's some of those or sorry, some of those very weird work that we have to do, and we don't enjoy that much. Maybe some people do, but I'm just sort of speaking for my. I just hate all of this, especially writing long and long documentation. So the LLMs are good at doing that as well. And again, it's not as a whole, but you can sort of take one function and sort of ask it to refactor, standardize, and sort of produce a documentation so that you can sort of club everything together. And then the code testing, which is one of the most important and crucial element of software engineering, which is it's good to write code. Um, but we all know that unless you write a code which is not proofed by either your colleagues or by some system, there's a good chance that it may or may not sort of hold true on the production floor. So code testing is also something which is very interesting, where we are looking out for LLMs to help us, where we are looking out for LLMs to give us more scenarios where we may not even think about, or we may not even sort of figure out that, oh, this could be a problem in production. So these are a couple of those sort of scenarios, which is going to sort of help us enable and sort of effectively scale the productivity of developers. And again, all of these things, the moment you experience them, they're all sort of disconnected. So it's not a single tool that does everything. It's different LLMs and different versions of the LLMs that do all of these things separately. So when you have to think about putting this at your end, do not forget that you have to sort of connect all of them together to sort of make it work for you. And we'll see those examples. It'll become more clearer to you that why I was saying that in the first place. But it's important that these are all sort of disconnected small elements, and they had their limitations. So when we say things like, oh, LLMs can do code generation, it's not like it's 100% solved problem. So yes, it can do code generation, but there is going to be limitations. There are going to be pros and cons of doing it. There are going to be privacy issues with it. There are a lot of things which you have to keep in mind. So it's not as hunky dory or as hyped as people make it to be. Again, I'm not saying you cannot do anything. You can do a lot of things, but when you have to finally do it at your end in your company, there are a lot of things that you need to keep in mind, and we'll talk about that, of course, as we move on. So these are the specific things that we'll see, scenarios that we'll explore and experience. But the impact in the business is amazing. You have scale, you have cost, benefit, experience, revenues, and a bunch of things, right? Bunch of things happening in this. Again, this is the part where I'll not sort of go into too much details, because you can sort of make sense of why this would help you either scale or save you cost, or sort of help you generate more experience, more revenue out of it. So these are certain capabilities that we just talked about. And again, one of the most important things also is that, and this is a question which a lot of companies do ask, which is a lot of our customers are asking that, okay, fine, we do the sort of enablement, or let's say effective automations of a lot of things, but how does it affect us, right? So how does it sort of really affect us? And there are things which are beyond the cost and the revenue. Of course, you end up saving a lot of cost because you're sort of automating very interesting, important things. But there's a lot of things which also become part of your culture. There's a lot of things where developers are happy because they don't have to sort of do a lot of those uh, low levels tasks, which sort of makes them not very productive. So it's like, with the help of LLMs, you're going to sort of get things more out of your development. And that's the kind of pitch that we are trying to sort of understand, right? Now, coming to the most important part, so we've understood what are these specific scenarios, what does it really help you, or your organization as a whole, and what are those things that sort of connect both of those. The next thing that we need to understand is that how is Google Cloud thinking about all of these things, which are also sort of important. So we saw like the use case things and everything, but now we'll see as an enterprise, how do you, how do you think about code generation and all, because it's not just about code generation. You need to have enterprise readiness, so you need to have data privacy and security, which means, okay, I'm going to ask very critical business logic to these models. Does Google Cloud provide me a surety that, hey, we are not going to look into your prompts, and we're not going to sort of retrain our models with the prompt and the outputs that we are giving you, right? That's an surety you need. You may not have that surety in the open as well as in the free tools that we use outside, for example, Bard and Chat GPTs and all, because they are essentially they are built on a consumer side of the world, right? Like, you're not paying anything to use them, so it's free, which means that there your data is going to go, and they will use those data to do the training. So it's very critical that you do not put your user journeys, you do not put your critical business logics on the open internet, open LLMs, right? But Google Cloud here sort of makes sure that, a, we don't read your prompts, read as in we don't use it for the training, we're not storing it for the training, we're just storing it for the logs and everything. But we sort of give you that SLA that, our models are not sort of trying to do anything fishy. We also sort of do copyright protection. So for example, whatever code gets generated, we also make sure that we give the recitation, or the citation of from where this code is coming, so that, in future it shouldn't happen that, oh, you use something and then one day one company is saying, hey, this is the code I have copyright on, and you can't use it, or something like that, right? So we sort of also make sure that you get the citations out of things, in that sense. The data sovereignty is also important, because, again, for a lot of companies and customers, they cannot sort of send the data outside of a particular location. So we also sort of support that with our models, which is very important. And the last one is the responsible AI, which is the very core of how Google sort of does most of the LLM work and things like that, which is, you can always assume by default that whenever we are building models, we are keeping all of this thing in mind, that, a, it should not use anything illegal, it should not use data which we don't have licenses to, so that later when you are in the stage of sort of doing these deployment, it shouldn't so happen that, suddenly there's something that stops you from using all of those things. So these are sort of, again, enterprise readiness that you have with the models that you're going to use with us. This is my favorite. The second thing, which I think all of you would also appreciate, because all the examples that we talked about, the generation, completion, and things like that, it's good. It's sort of leveraging the learning that Google model has done. But oftentimes, as a customer, as a developer, you're like, hey, you know what? It's all good. The learnings are good. It has sort of generalized well. It understands when I ask it to add two numbers, and sort of it knows how to generate a Python function for it. However, I don't want, there are a lot of standards that we have internally in our company. There are a lot of standard ways of writing code. Your models do not have those. And it's not like because that data has never been fed to it, right? So a lot of our customers also want that, hey, can we take our code bases with the assurance of Google that they will not misuse or use that for their own models later, but at least give us a way to tune it and use that version of the model rather than the foundation model. And that is what we also provide you. So we give you a way where you can actually take your code bases and train the model, or sorry, not train, the correct word is tune the model on your database, so that the nuances that your code bases have, whether it's, how you write function names, how you write different logics, how do you define variables, maybe there are a lot of sort of custom logics that you do. And that's one of the things that, the flexibility we provide you as part of the service. And that's why I said this is one of my favorite things, because I've seen the kind of things customers are doing with this. This also means, by the way, and this is one of the most important use cases, which is the code translation. So many companies sort of move from let's say, for example, very recently, I was discussing this use case with one of the customer who was going from Python 2.8 to Python 3, or in general Python 2 to Python 3. Like that's a migration which is, it's not very complicated, but it is one of those things where customer is trying to sort of see whether they can use Kodi to do that translation. So out of the box, you can actually do translation of Python 2 to Python 3 out of the box. But the concern here is that they have written this code in a certain way. There are certain styles and principles that they have used in their code base in Python 2, and they essentially want all of that to also be part of when that translation is happening using Kodi. So that becomes a more better solution, because you're not just doing Python 2 to Python 3, which is by default available, but you're also sort of adding your customization that, oh, by the way, do this, but make sure that you're doing this kind of a formatting, because that's how we have done formatting in our code bases. So that's the kind of applications you can do. In fact, while we support a lot of languages, there are some languages where the translation between them are not as good as you may want it to be, right? But maybe for some reason you have data of migration. Maybe you're going from very old language to a new language like Rust, for example, and you do have good examples of that translation, and you want that, currently your lot of developers are writing this, which is a time consuming, very costly affair where you have to do with this, which means you can actually take that translation data, feed Kodi or tune Kodi, and sort of let it learn through those translation and be like, okay, now I know how to take a very old language, let's say COBOL or something, and then translate that to Rust, and you get better results because you're using your own data. And again, when I say all of this, it might sort of look, um, to some of you, it might sort of look very unsafe, because you're like, hey, this is not good that we are sending data to this. But sort of be assured that, because these are all the part of the SLAs that we try to keep when we do this. Okay, and the third thing, and this sort of comes back to how we sort of think about, um, as a whole ecosystem. So, like I said, this is not just sort of one service that we are focusing on. There's a whole ecosystem of things that we are trying to do across developer productivity. So we have platforms that we are building, we have ecosystems with other languages and tools and technologies inside Google, that we are trying to sort of inbuilt all of these things, and then we have third party extensions. So for example, let's start with the first one, the enterprise platforms, which is the Vertex AI and Do It AI. Vertex AI is where we'll do all the code examples and do the code generation and all. This is more for builders, and I'll come to the difference between Do It AI and Vertex AI in a moment. And by the way, there are a lot of other sessions which are going to talk about Do It AI. If you're interested, please make sure that you're sort of attending those sessions just to see the difference. And I'll come to a very basic difference so that you at least know what they are, and then to learn more you should sort of attend those sessions. The second is the software ecosystem, which is, again, for example, Google has tools like TensorFlow, JAX, Kubernetes, Collab, and there are many other sort of open source things and ecosystems that Google has built. So our focus is always that, it's not just a LLM that we're giving. We're also sort of making sure that, okay, next time you're going to write JAX, or next time you're going to write oops, my bad. Next time you're gonna, let's say, write TensorFlow, you should be able to use code completion using the same model, so that it's easier for you to develop TensorFlow models, or it's easier for you to develop, let's say, Kubernetes scripts that you would have to write for the automation. So that's the second level of ecosystem push that we are trying to do, so that it's not just you building everything on your own, but everything which is part of the ecosystem from Google and many other which will follow soon will also sort of have these integrations, so that your development is easy in those platforms as well, or those projects as well. And then the third party integration is, again, something which is very, very important. So for example, with Replit is one of those software as a service solution where you can actually run any programming language. You can do all of your development online. be it web development or be it DevOps or anything. You can sort of do all the things online. So we are sort of providing our integrations to those services so that if for whatever reason you're using those services, you have a native way to use these models in that sense. So something similar to like Jira, GitLab. Again, a lot of startups and a lot of companies do use GitLab to manage their Git repositories and all of those things. Jira is again sort of one of the very powerful ticketing system, which helps you sort of keep track of a lot of things which are going on, tickets and everything with respect to your software. So we are sort of building those integrations ground up so that again it's easy for you to sort of, let's say you're like, hey, all my code is sitting in GitLab. Can I use Cody, which is the model for the code generation, to sort of learn through that and then sort of do a generation using that, right? So that's why we are sort of focusing on all of that. So again, just to sort of cover, at the very low level, you have the raw models where you build the whole ecosystem on your own based on your ecosystem and integrations and products. If not, then you have all the ecosystem, Google ecosystem across open source models, across open source sort of languages, tools, and products, and things like that. So you can either use the models there to sort of enhance your development in those sort of ecosystem components, or you can focus on the integration so that you can bring your data, again, securely bring your data from that. So that's like a, the overall story as a narrative that we sort of work with when it comes to code generation and code completion as well. Okay. Now this is where it's very important for us to understand what exactly is the difference between Vertex AI and Duet AI, right? Like, because again, this is something you'll keep hearing a lot, so it's important that we understand the difference very early on. So the way we like to think about this is, Vertex AI is more for builders and Duet AI is more for users. So there's a difference in a sense that who is the persona which is going to use the product. So if you are somebody who's a builder, by builder it essentially means that you're a software dev whose focus is on to build applications for your companies, for your customers, or maybe for something internal. But if you're trying to build the services out, then Vertex AI is what you should focus on, where you have the Cody APIs and many other APIs that can help you build those services. But if you are on the other side of the spectrum, which is, and again, it doesn't mean that one is good and the other bad. It just means that there are two differentiations in terms of who is supposed to use what. On the other hand, Duet AI is more like a built tool for you for the Google ecosystem. So maybe you are using Google Workspace and you need something where in your Google Docs you're trying to sort of say, hey, can I use AI to write a letter that I'm trying to do? Or can I use AI to sort of, go through my document and point out any issues in it? So this is the kind of things Do It AI is built to do. So be it your Google Sheets or Google Docs or Google Presentation, or you can be on the Google Cloud thing. So if you're learning how to sort of deploy a simple Python application using Cloud Run, this is where Do It AI can help you do that. Like, it can tell you steps that you need to take in order to do the deployment. So Do It AI in that sense is essentially for users. It's not for development. It's for you to, it's a build product which is going to help you do things which you're doing on those platforms. So it's helping you do more with those platforms. So initially you would actually go on Google and you will find, oh, how do I do this in Google Cloud? How do I do this in Google Cloud? But now you don't have to, because you can just sort of do the same queries and Do It AI, and then sort of it helps you get those answers. The interesting part here is that Do It AI is built on the Vertex AI or the Cody platform. So you can see that, it's a good example for you, where if you want to know what is the best applications that you can build with these raw sort of APIs, you can see Do It AI, which is our product that we actually built using the same models that we are giving you access to, so that you know that okay, this is not just sort of some fluff thing or some random thing. you can actually build production grade application which can be used by millions of users, which is what Do It AI has been so far. So that's the difference. Very important for you to keep in mind. Duet AI, as of now, doesn't have API or a way to sort of extend your things. There are certain things which are coming, like you can input your own data in Duet AI and all of those things, but it's a very different product. It's not the raw form of product where you can sort of build everything. So if you're a builder or an engineer, and your goal is to sort of build new tools for your organization to sort of increase developer productivity, you will go towards the Vertex AI side. If your goal is to just make sure that your developer productivity using Google ecosystem should be better, you would use Do It AI, because there you don't need to sort of build anything. All of this is sort of built for you. You just need to use it as a tool. So that difference is very important. Okay. Now, I'm going to sort of, I wanted to cover all of this, which is what are the different APIs that we have and what are the different things. But what I'm going to do is I'm going to stop here, because I want to show you all of this in the notebook itself so that you see it live rather than sort of me spending too much time on the presentation. I'm sure some of you will appreciate, but some of you may not. But let's just sort of, again, you'll get the same information, but I want to sort of make a balance of not spending too much time doing the presentation. All right. So first, let's talk about, and I'll take the questions towards the end. So let's talk about what notebooks I'm using. So if you have already not known this, but most of the demos that you're seeing here, sorry, not most, but some of the demos that you're seeing here, they're available online for free. Like the notebooks for them are available online. So if you see this, for example, and you can sort of just take a screenshot, or just note down a name, which is Generative AI has a folder where all of these notebooks are present. So this is why I just want to show you where the notebooks that we'll do are present. So if you go to the main folder, and what I'll do is I'll probably sort of put this in the chat and let Aga and Timon sort of also share it with you if they can. If not, again, you can just sort of copy paste by seeing it on the screen. Okay, so in this, we're going to go to the language, and in language, there's a folder called as code. So essentially, the path that you are using from this is generative AI language code. And this is where most of the code notebooks are. And when I say code, essentially means that everything to do with code generation, all the notebooks are available here. So we are using these notebooks. The notebooks that I'm going to show you or walk you through are available here. Now, the three notebooks which are very important, and we'll not sort of cover the RAG one for code because, and I'll see, like if we have time, I'm sure I'm going to spend time with that as well. But very important for us to do the first three notebook. How do you access and run these notebooks? And again, this is something you would have to go through the instructions that we have provided. But just to give you a heads up, there are multiple ways for you to run this. One of which is to, in fact, just run it on Colab. Colab is something which I'm sure a lot of you know what it is. And I'll so basically the one that I'll show you is a notebook that is running on Colab. So I'll show you the Colab way, but you can actually open this in Vertex AI Workbench. Now, there are two things, in fact, just one thing which is required for you to run these notebooks. Unlike Google AI, Google API, which is outside of the cloud, which is a free API, you just have to sign in and get the key, and then you're up and running for all of those things. Cloud is slightly different, right? Because for you to access these APIs, you need a paid account. And that's what Timon was saying, that we are helping you get those things. We are helping you get some credit so that you can sort of play with these things. So please follow those documents. They help you understand how to sort of set up those things, because unless you have credits or a paid account, you'll not be able to use any of these notebooks to start off. The second is, if you for some reason already have access to Google Cloud and an account which is tied to a credit card, maybe it's your company's account or something, These notebooks don't cost like millions of dollars suddenly, right? These are like very small $1, $2 things, kind of a thing. So if you already have that for some reason, you're already using GCP or you already have access to GCP credits, you still can run. And I'll tell you how to sort of do that, right? So again, everything before that, I'm assuming that you will figure out how to have an account which either has credit or which has connection to credit card, so that there is no issue of account billing or any of those things, right? So please reach out to our folks and they'll help you out with these things. So these are the notebooks, and the way to run this in Collab or Workbench. Workbench is very similar, but Workbench is essentially, you can think of as running Jupyter Notebook with the custom machines that you have. So it's like setting up a Jupyter Notebook server on Google Cloud, and you can select your own machine. So you can say, hey, I need 20,000. Sorry, I need this kind of a GPU. I need this much RAM and things like that. So that's what Workbench is. Collab is the Collab, the way the thing that we use. Okay, so again, I'm going to go back just so that you know. Please take a screenshot. We are accessing the notebooks inside generative AI, language, code, and then generation, completion, and chat. So these are the three notebooks that we're going to do right now. And they are part of Google Cloud Platform official GitHub, in which there's a folder called as generative AI. So you just have to, and here's an easy way. If you're trying to search this, here's how I try to search this. So just say generative AI GCP GitHub. That's all you have to do on Google. So just say generative AI GCP GitHub. The moment you hit enter, the first link, for some reason our SEOs are good, and this is the first link that you'll get, and that's pretty much what you need to open, right? So again, just quickly, just search generative AI GCP GitHub. That's what you need to do. When you do that, the first link, or maybe first or the second link, either way, because there's also something like generative AI Python. That's not the link uh, that you need to access, right? So um, this is what you need to be in, and if you want to be sure, this repo has 4.5 stars, so you can sort of make sure that you're on the correct one. All right, so once we are on the particular folder structure, I'm going to start with code generation lab, or let's say the code generation notebook. The way to open this notebook is run in Collab. So I am going to do this as right click. And when I say open link in new tab, what you will see is that that notebook suddenly now opens in Google Collab, right? So this is pretty much the same. This is why we have given you the direct link. And then couple of things that you need to keep in mind for you to run this on Google Collab. If you're running this inside Google Cloud, or let's say using Vertex AI Workbench, you do not need to make the changes that I'm going to tell you, because those changes are specifically for Google Colab. In fact, we do mention this, in the whole notebook. So, for example, the first is we ask you to sort of do the installation of Cloud AI Platform. We ask you to restart because once it installs, it needs to sort of upgrade itself, and then it needs to gets restarted. And then we specifically tell you that if you're using Collab, then you need to do the authentication. If the same notebook is running inside the GCP, you don't need the authentication because you're already inside the Google Cloud, right? So first thing is you need to authenticate. Now, often people sort of ask this question that, hey, which account should I authenticate? Or I'm using my personal account and I did this and nothing is working. So you have to be careful. This again goes back to the first point which I said. So A, you need GCP access either through credits that we give you or some account that you already have, whichever is that account where you have credits either that you have been given or you already had credit, like the startup credits or the free $300 credits or whatever. So you need to have that billing account enabled. Once you know that, that is the account through which you need to do the authentication. So be very careful. As you can see, for example, I'm currently using the my Google account. So this is what I'm using because I have credits in that account. But if I were to use, for whatever weird reason, let's say my personal Gmail account, I would not be able to run this notebook, right? So be very careful. And we do mention this, and this is why you will see that in these notebook, these are commented by default, and you would need to uncomment them because you're doing this on Collab. You don't need to do this in Vertex AI Bench. The same thing you need to do on here. So again, you will notice that there is something called as collab only, in which uh, something is again sort of commented out. Now, this is again important because um, once you do the authentication, so you've already said that, hey, this is my Google account, Google Cloud account. Let me sort of do things which are associated with my account on Google Colab. So the next thing that you need to do is you need to tell that, hey, in that Google Cloud account, there's a specific project that I'm working on, which has, and again, if you know, this is a very basic Google Cloud thing. If you do not know a lot of details around it, I would suggest that there are intro to Google Cloud, which you should take because it sort of covers everything. But the very basic premise of Google Cloud is that everything works under the ambit of project ID. So once you're inside Google Cloud, you sort of create your own project ID and you give access to all of those services in that project ID to that specific user. So that's what we are doing here. So what we are saying is, okay, whatever the project ID is. So for example, it could be my project ID 01, whatever that is. So you do sort of mention that. So just to sort of quickly show you, let's say I go to my cloud, and then on top you can see that I have a bunch of different sort of project IDs. So Lavi LLM experiment is one of the project that I have created, and the ID is this, which I copy, and all I have to do is this. So I copy this, and that's it. That's all I need to do. So now what will happen is it will establish the connection with my ID, which has the billing account enabled, or let's say the credit enabled. It knows that that is the account that needs to use to run these algorithms. And in those accounts, this is the project that has access, and this is the project that is going to run. This is a very necessary step. Like I said, unless you do that, you'll not be able to sort of run through these things at your end later, right? So let me close this because again, like I said, I've already run this just so that we don't, while doing all of this, we don't get into issues live. So let me show you how each and every step works. Right, again, going back, how do I come to this notebook? You should remember that you are first do Google search, come to generative AI, then language, then code, and then code generation.ipynby, and then you click on run in Colab, which opens something like this, and then this essentially sort of you go step by step, right? So the first is you do the pip installation of the AI platform. This is the SDK that you need for you to access all the LLMs and the Vertex here. When you do install, you can see that it actually asks you to restart the runtime, which is again important. And you either can restart it just by clicking here, or you can sort of run the second cell, which automatically does the same thing. So you do these two things, and then you can see in my run, I've actually uncommented the authentication. And when you run this cell, it all will do nothing, but it'll just open a new sort of short window, and that short window will just do the authentication with your account. So this is where you have to be careful, right? This is where make sure that you only authenticate with the account where you have the credits and the billing enabled, right? Do not authenticate with your personal ID or anything. And be careful because for whatever reason, if you have personal account and you have added your credit card, I just want you to be very careful here because sometimes I've seen people had something in their personal account, they've actually added credit card, and they didn't think about much and they just kept on authenticating, adding a project ID, started using everything. They were thinking that they were using the credit account or the free account or something, but it was not the case. And then later they played around with things, and it was not like they had like $1 million bill, but they had like $1 or $2 bill that came towards the end. and they got surprised. So I'm just sort of letting you know that be very careful. Only authenticate with the accounts where you know that you're okay spending, either in terms of credit, or it's your company account, or it's an account where you have money, and you're okay with it, right? So once you do that, the second thing, you can see that I'm actually adding my project ID, which is the Lovey LLM experiment. You would have to create your own, and in that you would have to sort of um, um, give the access to the collab. And then once you're done with this, you basically first import the model. So you can see the first thing that we're doing is we are learning about code generation model, right? The code generation model, and we sort of call that. In fact, let me sort of increase the cell. I'm not sure if this is visible. Okay, much better. So code generation is the class that we are going to use, or the method that we're going to use to do the code generation. The name of the model, this is very interesting and this is very important. There are going to be, so again, these are palm models, and each palm model has different versions. And again, if you've been following what LLMs are, and if you've seen our many other sessions, you would know that Palm has different versions. You have Code Bison, you have Code Bison, Text Bison, you have Text Unicorn, and things like that, right? Like there are different versions. So this one is the Code Bison. At the rate is the version. So at the rate latest is always the latest model. At the rate 002 is the current stable GA version. So you can imagine that maybe, let's say, in 2 years, it will be at the rate 10th or something like that, 010 or 012 or something. So code Bison is the size of the model. It's like the medium size of the model of Palm. So the name initially identifies what is the size. So the unicorn models are like the largest one. The Bison is this, and then you have Gecko, which are like the more smaller versions compared to Bison. So code Bison means that you're using Palm models which are tuned to code, and it's a medium version of Palm. And which version of that is? It's the at the rate 002. So we were supporting 001 before. Now we are graduating to 002, which is stable and in GA. So that's how you know that you're supposed to do Code Bison. What can you do with this? So Code Bison is a model that only supports code generation. You can't do code completion, right? You can't do chat, one back and forth, or let's say multi-turn chats. Those are things which are not supported in Code Bison. But you can do things like writing a function, writing a classes, web pages, unit tests, doc strings, translations, and all of those things. It does support lot of languages. In fact, if I go to the official documentation, which is, again, if you have opened up this at your end, we do give a list of all the languages. So if you come down in the official documentation, you can see which model. So Code Bison, Code Gecko, and Code Chat Bison. These are three different models that we have, and what are the languages that we support, and which model sort of supports which. So again, if there is a language that you don't see there, you have an option to tune it or train it using your own data. Google doesn't sort of provide you that data to do that. All right, so let's start with some of the examples. So again, what is more important for us to understand at this point is that these notebooks are going to show you, let me sort of put that expectation right. So these notebooks are going to give you those different kinds of design patterns for prompts, and you will see how you would solve a problem of something, which is, let's say, a problem statement of a code generation. But what are different types of prompts that you can write? So we'll see those examples, and we'll sort of learn through that. Oh, I can do this also, I can do this also, this is how I can customize. So it's going to be the same problem but seen multiple different angles through different design patterns. So that's pretty much it. And I will sort of show you with different languages as well. So you will see that, oh, I can do this in C++. Oh, I can do this in Scala. I can do this in Python. So things like that. So every design pattern that you see while you see this in a specific language doesn't mean that you can't do the same design pattern with, let's say, other languages. It's just an example. Okay. So let's start with this. The first thing that we do is we load the model. So we use the same method of the class that we have initialized before. And from there, we are again sort of loading the model. And sometimes sort of people do get confused. It doesn't mean that, there's a model that gets sort of downloaded and it gets loaded in the memory. It is just establishing the RPC connection. So it's like it's a simple API call that you're going to do. So again, be careful. It's not any downloading and then sort of doing anything locally. It simply means that you've established an object, and that object is going to do REST API calls with the frozen Google model. You send your prompt and then it returns something, and that's what you see. Which means oftentimes people ask this, oh, does this mean that I always need internet to run this? And the answer is yes. You cannot run this notebook. And of course, anyway, we can't run this because there's a lot of things which happens on that. And Colab is again hosted. But if you were to sort of even run this locally without using the internet, you would not be able to do that because this loading of the model is establishing connection with the actual frozen models, right? So be very careful. Sometimes people sort of do get confused. Okay, once we have that, what we're going to do is we're going to use the object. So we have defined the object, which is code generation model, and then we are going to use dot predict, and then we define the prefix. Prefix here essentially means the prompt that you have to write. And I'll slowly show you all the different parameters that we have. In fact, you can see there are only three parameters in the code bison 002. So one is the prefix, which is essentially the prompt, like the whatever you want to write. The temperature, which essentially means that you do you want the generated code to be more creative, or do you want it to be more deterministic? So if you want the code to be something deterministic in a sense that it gives you the most obvious and expected answer, then you keep the temperature towards zero. If you want the outputs or the answer or the code generation to be something creative that you never thought of, or it's a different method of solving the same problem, and you want the model to sort of think outside of the box, then you keep things closer. Be very careful. It just doesn't mean that, oh, I'm putting temperature zero, which means I will always get the correct answer. Or if I put the temperature close to one or higher, I will always get the incorrect answer. That's not what temperature means. It is simply a way for you to choose the words or the tokens that are going to be predicted. So if you keep the temperature low, the next tokens, in this case next part of the code, is going to be very sort of expected. Like, that's pretty much how you would write, or anybody would write, or most of the internet data would sort of go in that direction. Creatives are more sort of out of the box solution, so keep this in mind. And the last parameter is max output token. The default here, at least for code bison 002, is 2048. 2048, yes. And the range is anywhere between 1 to 2048, again in tokens. So you can sort of pretty much have 4,000 words, 4,000 characters in that sense, right? So these are the things to keep in mind. Let's start with the first one. So I'm writing a prefix, which is just a prompt. I'm saying write a Python function to do a binary search. And then I simply do dot predict. I get the response and I do response dot text. Response dot text is important because you collect the response. Again, you can imagine that this is just an REST API call, which means the response will come, and then it's going to be a JSON object. So you need to, and it sort of forces that JSON object to dictionary. So you convert that response, you get the text part of that, right? And you can see that we are currently getting binary search function, and it sort of tries to solve this in the most common way. The reason being, if you see the default value of temperature, it's zero, right? So it's anyway going to give you the most deterministic or more expected answer. And this is where I said, let's say you want a more creative solution to do. Oops, sorry. you want a more creative way to sort of solve a binary search problem, that's where you will sort of try to keep the temperature sort of slightly high and see how it's sort of, it again, it doesn't always mean that it'll suddenly change something new, but maybe that it might sort of take a slightly different approach to solve it. So that's how it is. Now let's see different patterns of how you can customize the or sort of ground the generation of the code, right? So let's take the second example. In this, what we're saying is write a Python function that can do a cosine similarity between two vectors, named as calculate cosine similarity, and two input arguments as vector and vector 1 and vector 2. So this is a very interesting prompt pattern because in this you're doing two things. One, you're carefully defining the name of the function. So you're very specifically saying to the model that, hey, you know what? I want you to do this function which can do a calculation of two vectors and do a cosine similarity. Very common calculation for people who are doing, let's say, embeddings or REG and things like that, right? It's like a very simple dot product of two vectors. But you're defining that the input argument should be called as vector 1 and vector 2, and the name of the function should be called as calculate cosine similarity. Again, everything remains same. In this, we are also sort of controlling the output token. But if you see the generation, you would notice that it took the suggestion that you said. So it is actually keeping in mind the name that you said and the name of the variables that you defined, right? So this is good. You can control this. Again, this is one of those examples that we were talking about, right? Where let's say your company has some very standard way of naming things or naming a variable, you can actually ground the prompt of whatever you're trying to do and then make sure that the grounding information is given as just an example, right? So this is the second example. You can see that this is sort of doing and giving us the response to it. Okay, next design template. The next design template is sort of what we typically refer to as prompt templates, which is very common in LangChain also. But here it's just a very simple example where you're saying, what if I keep this very dynamic? How do I make this more dynamic? Because every time I can't write all of this, right? I want the prompts to have some predefined, let's say, logic, which is like, okay, the name of the function should always be like this. The name of the variable should always be like this. And there could be like 5 or 10 different rules that you have as part of your organization. You can define those rules always, and then the user always has to give two things: one, which language they need, and the second is what is the problem statement, right? So you'll start seeing things of those level, right? So the first is, let's say we define, okay, I need the language Python, and then we use the simple f strings. Again, this is not fancy, there's nothing fancy going on, and this is not a feature of the LLM model, right? This is something we're doing from a Python perspective. So we use f strings, and we say write a, and then whatever user defines. So here I can sort of do C++, or I can say Java, whatever I select or sort of write. And um, in this, what I'm saying is a function that can input unsorted array or list and return the sorted array or list. It should not use any pre-built function or a library. So again, the first one, like if you think about it, the first one is the problem statement where we are saying explicitly that take unsorted array or list, because we're trying to do this in Python, and return the sorted list and array. And we know this, that Python has inbuilt functions to sort of do this, right? Like there are many functions, like list functions can be used and all. So we gave an instruction. We said, hey, do this, but do not use any pre-built functions or library. So again, you're giving some custom instructions so that it sort of grounds itself into generation. So let's see what it does. It sort of starts with saying this to be a bubble sort. And again, we didn't ask it to do bubble sort, right? We said was something very vague. We didn't mention that, hey, please use this sort, that sort, or any kind of sort. We said, I want this going to be unsorted. I want this to be sorted. So basically, it took that and it is doing the bubble sort. We could have mentioned it, but this example sort of shows that even if you do not know what bubble sort or any other kind of sorting algorithms are, it is going to sort of infer that and give you whatever it thinks is best. Again, It doesn't mean that bubble sort is best. It just gives you that because you're asking it to do that. And then you can see that it doesn't sort of import any new library. So all it is doing is it is using default for loop, and it is sort of doing iterations over array, matching each element, again whatever the bubble sort does, right, which is going two elements at a time, sort of doing the sorting, moving ahead, doing the sorting, moving ahead, and things like that. In fact, it goes beyond, and it's also sort of doing whether the array is sorted or not, right? So it sort of gives you two things. It gives you a function to sort, and it also sort of gives you a function to check whether it is sort of sorted or not, right? So again, very interesting. Again, you're able to sort of add a dynamic element as well as an instruction that please do not do this or that. So let's move ahead. Let's see some other example. So in this one, this is very interesting because what we are trying to do here is we're trying to make it more dynamic, right? And again, whenever we are showing you this, think of it as, oh, I take this and I put this behind, let's say, an API or a simple UI in my company, where now a team can sort of play with these options and then they can run the API using these dynamic operations. So, for example, I'm saying this time choose the language, and this is again uh, where we are sort of defining a requirement separately. So the prefix here, or let's say the prompt here is create whatever Java, Python, whatever, to parse specific file format. So it says JSON. So to parse JSON and extract whatever the extract info, let's say names, with the following requirement. So essentially, the goal here was that we want to extract names from a specific kind of data. In this case, it's JSON, but it could as well be a TXT file, it could be a docx file or something, right, in a specific language. And it's not just that you just extract the names. There is a requirement associated with this. There's a specific rule associated with that. That rule in this case is the name should be name should start, actually the spelling mistake, oh sorry, grammatical mistake. The name should start with a capital letter, which essentially means that you need to only pick names which has a capital letter. So, and again, it may not make sense like why pick only with the capital letters, but you can see that like we can define these specific things. There should be no duplicate names in the final list. So again, you're explicitly mentioning that once you sort of save everything in a list, and then make sure that you run the an operation where all the duplicate elements are removed. So you sort of change the things above, and that sort of changes the prefix in the bottom. And then using that, because you're keeping this as Python, it sort of comes up with the logic. And in the logic, very interestingly, it also sort of shows you how to open a JSON file, right? This is something which you've not mentioned or asked for. But it was sort of smart enough to say that, okay, if you have to do this, first you need to load a data file, get the JSON, and sort of load that whole data into something. And then sort of go each place. And then also, because you need to store the unique name, right? Remember the instruction which says, no duplicate names in the final list. So it is sort of trying to make sure that it is always unique. And that's why it's taking a set of that value. The other is the is upper. So again, it says the check if the number starts with a capital letter. Again, very specific instruction that you gave, and that is the instruction that it is trying to sort of make sense of, right? So this is again a very interesting design pattern in this sense. All right, let's see a few more. So the other one is this. Now you'll start seeing sort of deviation from Python. So let's quickly sort of see. So this is the C1 where you define the problem statement. You say find the smallest element in the unordered list, and then you sort of define a prefix, and you can see that it sort of gives you a C++ function. Oh, by the way, when you actually open this, and Python is easy to test because you can sort of just test this in the Jupyter notebook. There is an open sort of free one something called as onecompiler.com. What it does is whatever code that gets generated, if you're before even sort of implementing this in your workflows or sort of establishing a connection between what is there, and this is not again something I'm saying from a production perspective. Please do not do this in production, right? This is more like when you're evaluating and when you're playing with it, you also want to sort of not quickly go and sort of write a package to execute the code that you just got. What you can do is, let's say I had this, the C1, and I want to check whether this is a correct one or not, right? So I can just copy the code. I can go to one compiler and I can go here and say, all right, let's see where C is. There you go. Here is C. And I can sort of just put this and I can run this, right? Just to see whether the code which is being created is correct or not. So you can see that it says the smallest element of the list is 5. So whatever we have given as an example, 10, 25, 30. So it's correct, right? It's correct. So we whatever got recommended to us as a code, you can actually use onecompiler.com. Again, it's not a selling of this their services or anything. We don't have a partnership or anything. I'm just giving you that if you're trying to evaluate many different languages and you do not want to sort of go through the whole process of executing actual code, here's the best way. Just copy here, run, and see the code is correct or not, so that if something is wrong, you can sort of mention this in the prompt saying, hey, make sure that you don't do this because that is giving you the wrong output, right? Okay, similarly, let's see a different design pattern which is showing you C++. Now, this is very interesting because sometime when you're trying to solve a problem, so see a problem statement. First is we define the language. We say sort an array in one swap whose two elements are swapped and rest are in the sorted order. This is a very DSA question, data structure question. So for all of you who are coming from a background of learning lead code or solving DSA problems for FANGs and any other companies, you might have a nightmare suddenly just by seeing this. But again, in a fun way, the most important thing here is that first we start with a very complicated data structure problem statement, but very importantly, we define an example. This is important because we are essentially telling the algorithm that, hey, I want something and I'm going to give you a input and output. So I have input 1537, the output is 1357. And it doesn't stop there. You can actually define the whole step-by-step process as well. You can say, okay, if I have this input, step 1, you're supposed to do this. Step 2, you're supposed to do this. Step 3, do this. And then the final output. So this is again like few short prompting, right? Where you ask something and then you give multiple examples of how to arrive at that answer. This is also very similar to chain of thought, where you are essentially giving algorithm that, hey, this is how to solve the problem. Now take this into consideration when you provide a code. So very well, if you go and sort of do this, it sort of takes those. In fact, if you notice the input that we have given 15379, you can see that in the main, it actually takes that example. And again, we can do the same thing. We can sort of take this code and we can copy this. I'm going to go to this place. I'm going to go to C++. There you go. 17359, right? Okay, perfect. So you can see that again, this code sort of runs, and I think the output is not correct because it shouldn't have been 17359. It should be 13579. Yeah, so something went wrong, right? So, and this is why you have to be careful. This is why you have to sort of make sure that the output is coming out, and you're also sort of testing it so that you can tell it that where it went wrong, right? Like you can do those things. And I'll show you one of those examples in a moment where you can sort of use chat to do this back and forth conversation. Currently, you can't do back and forth conversation because this is code generation model, which means you ask it something, it gives you something. It doesn't remember what you asked before. So for that, we'll use the chat one, and we'll see that sometimes when you do get error for whatever reason, you should have a way to give it a feedback saying, hey, here's something wrong. I'm still getting the answer as this. Please fix this. And sort of it has that feedback mechanism. All right, let's take the second example. So again, this time we're taking a closure, which is one of the languages, and it says take a string and calculate if it's palindrome or not. And we are saying print the output with two examples, which is radar and happy. So you can see that we have palindrome radar, palindrome happy. So again, it took that as one of those things. Here's the other one, which is elixir. Print the first non-repeated character from a string. And then we are seeing take example of Mississippi and hello as an example. And again, you can see that it actually went through the whole thing. And again, the interesting part is it is again taking only those examples that you have given, so which is good, right? This is Erlang. Again, Erlang is supported. We are doing something same. We are saying reverse an array in place, take input of an array. And then again, we are giving example so that it sort of knows this and it sort of follows that. And you can see that it is sort of taking that. So like this, there are many different examples that you can play with. Now, let me show you how you can do something like SQL, right? So SQL is again something which a lot of you do. So what you can do here is again just to ground the SQL, because you know that when you do SQL, there are things that you need to keep in mind in terms of the metadata of the table, the styling of this, and what is that you're trying to do, right? How do you want to optimize the query? So let's see this pattern. In this, we start with a problem statement in which there is a preamble which says, hey, you're a developer working with e-commerce platform. The marketing team has requested a report on the total number of orders and the average order. So essentially what we need is, and we have given the context of that, and we are saying that, hey, what we need is, we need the task is to generate a SQL query to retrieve the total number of orders and the average order value for each product category for the orders placed in the, and then we give four sort of filters of it. So we say past month, given date range, end of each month for a given year, and the Christmas and the New Year's Eve. So this is like the problem statement that we have, right? To achieve this, we are saying, hey, just don't do randomly. Here's the metadata of the table where we define the metadata of the orders table. So you have orders ID, product name, category, order date, and order amount, right? So, and you also, by the way, define the type of it. So you say integer, string, date, decimal. You don't stop there. You also sort of define the styling of the code. So you say write a SQL query that follows the best practices, readable and well commented. So you're also sort of defining that. The second thing that you're defining is the performance requirement. So you're saying optimize the query for performance considering the potential size of the orders table. Consider using appropriate indexing if necessary. Again, very important. We do indexing when we can, because it sort of optimizes the results that we do with the SQL, right? Now, if you see the final prefix of it, so again, this is nothing magic. Like once you see this, you're like, oh, this is like simple, and that's, I would say yes, this is simple. It's just a prompt pattern that we have, right? So if you see the prefix now, it says solve the following problem statement. The given table is this. Follow the following code style. The following performance requirement is this, right? So it's sort of you're giving it those explicit instructions and then asking it to sort of do that. And very well, when it sort of generates the code, you can see that it actually gives you each of those four things that you asked. It says calculate the total number of orders and average order value for each product category in the past month, and it gives you, keeping in mind all the sort of metadata that you have given, right? It again gives you second one, which is calculate the total number, and again it sort of gives you all of that. Then it says calculate the total number of orders for each month for a given year. Again, it sort of gives you, keeping in mind what is that you're trying to ask. So this is very fascinating because again, you wrote the problem statement. You also gave the table structure, so it's easy for you in that sense, right? You can do something very similar for BigQuery as well. So we are again taking a different example where we have this table and we have defined each and every sort of structure of the table, and we are also explicitly saying that the language of the query that we need is the BigQuery, and then these are the kind of things that we need. This is the additional requirement that we have, and again it sort of goes through and gives you those answers. So that's pretty much it. But what I also want to sort of show you is a couple of examples where we are doing something more than generation. So far we were doing generation, but let's say we also want to sort of do optimization of the code, right? So let's take that example. So this is, we are using Haskell in this, and we are saying, imagine this is a list of integers. The problem statement is that calculates the sum of all integers. So that's the problem statement, which is a generation where we are trying to calculate the sum of all integers in the list. The additional requirement here is the optimization expectation. So it says the function should be efficient and recursive. The function should be polymorphic so that it can be used to some list of any type of number. So this is very interesting, because now what you're doing is you're not just sort of doing just a simple generation, but you're also trying to optimize this as per the requirement, like specific requirement. It could be, oh, I want the O log n version of it, or I want this kind of a version of it, right? So again, it goes through that and it gives you a specific thing. Similar example for Java. Again, we are trying to sort of do evaluation of the mathematical expression, and we are saying I want, the requirement is to handle all valid mathematical expressions, including those with parentheses, operators, and variables. So you're again being very specific. You're saying, hey, I just don't want to do this, but it should also sort of do this as part of it. So this is the kind of optimizations you can do, and you can see how it sort of went through and do a whole complex Java code where it is sort of adhering to the requirement that you have given. Here's an example of JavaScript, which is again trying to do this. Now, this is very interesting. In this, one of the important things that we're doing is the fact that the check the additional requirement, right? So we are saying the function should be efficient and scalable, as the JSON object may contain millions of products. The function should be easy to read and maintain. So again, these are some kinds of requirements that we always go through, and it's also a very complex problem statement as well, right? So it says a JSON object containing a list of products, and blah blah blah. It has ID, name, price. The problem statement here is that function that takes the JSON object as input and returns a new JSON object containing the following properties, which is whatever you give. And then it sort of goes through and it gives you a JavaScript where it maintains all the things that you've said, right? So again, this is one of those things which you can sort of use to do that. So one last thing that I want to show you, and then I'll quickly show you how you can do exactly the whole thing that we just saw, but this time you can actually do back and forth chatting, is the chat model, which is the chain of thought. So in the chain of thought, it is more like when sometimes you're working on a very complex problem statement, which is not like how do you add two numbers, how do you sort of do basic processing, but it's a very complex processing that you're doing. So for example, let's take this. So you want a C++ function where the input is, let's say, a log file, and what you're trying to do is you're trying to sort of extract certain specific things out of these log files, and that's the code that you want overall. So first thing is you define the requirement, other than the original requirement. The additional requirements is this should not use regex. The solution should be scalable and should scale linearly with the additional data. And you're being very specific. Again, you would not sort of put this, but this is as an example. The output should print a flag and port number both. Again, that's a very specific thing. All the variables should be properly in scope and should be declared only once. The variable should have a scope to be called in the main function. The code should be easy to read, and blah, blah, blah. It should have proper type hints and comments. So that's your additional requirement. But let's see what we do in the final prefix or the prompts that we are. And this is the chain of thought, because what you're doing is you're giving steps of how to solve this problem. It's just that sometimes you know the solution. It's just that you may or may not know the best way to write a code for it. So chain of thought comes in very handy in that case, which is, let's see step by step. So you're saying prompt one, what is the problem we are trying to solve? And it says identify the status of Spark executor actor system service and network log, and output true or false along with the port if true. So that's the thing that you're trying to solve. Okay. Again, you're sort of going through chain of thought. You're going through this step by step. Second thing that you're doing is what is the language you want to use to solve this problem? And you sort of again put the input as language. What are the inputs and the output of the function? So input is network log, output is Boolean value indicating this. So again, it's like a back and forth conversation that you're having. What are the steps involved in identifying the status of this? And then it goes and sort of defines one by one. It says split the network log into lines, iterate over lines, and search for the line. If the line is found, do this. If the line is not found, so it's like, like very basic algorithmic flow. And then what is the sample input that can be tested as a test use case? So this is the first time you're seeing that we can actually have sample use cases. So for example, if you see, wait, where is sample input? So you can see that this is the sample input, and it's sort of asking that, hey, what are the test cases that I can use? So we're not passing, but we're asking it to give us test cases. Any additional requirement, and then we sort of put the additional requirement, and then we say prompt 7, and then we wait for the LLM to give us the whole thing. Now when you actually see the code, it is so customized to each and everything that we do. Like you can see that it is writing the same comments that you actually wrote in one of this. So see this, split the network log into lines. You can notice that it is actually doing the same thing. Function to identify this, iterate over lines, and this, so far, right? If the line is found, return true along with the port number, otherwise return false. So you can see that it's actually following what you have given as the approach of solving that problem statement, and then sort of doing exactly what you have said, along with the test cases. So because you asked it to sort of define the test cases, it has given that test cases, right? So that pretty much is what I wanted to show you, that we have given you more examples. If you actually go through the whole notebook, we have given you many different examples of different languages, and sort of play with it. Again, what I said before is, if for example the chain of thought is given in C++, it doesn't mean that you can't do this in Python. You can very well do this in Python. It's just an example. So play with this. I think you will really like the whole product. One thing that I quickly want to show you is how you can do all the things, but this time, let's say you want things to be more back and forth, right? So for example, you can use a different model, which is a code chat model. So just like you had a code generation model, you can actually use the code chat. And this time you can say code chat bison at the rate 002. You can define the session. So the difference between this and the previous is there was no session there. It was just one-on-one. Here you define the session, and in that session you go back and forth. Like you say, please help write a function to calculate the min of two numbers in Python. So it sort of does that the moment you send a message. But you can ask a follow-up question because you ask this and you write, can you explain the code line by line? Now, if you really think about it, it would know, for it to execute this, it should know what it has done before, right? And it did. It actually took the same code that it gave previously and went line by line and explained you all the things. Then again, you sort of said, hey, can you now add a docstring, type hint, and pep8 formatting to the code? Again, it sort of took the whole thing because it knew what it was and then sort of did that. So this is a back and forth version where sometimes, like I said, I gave an example that, it's not always the case that you'll get the answer in one go. So you may want to sort of go back and forth and sort of keep on nudging the model to give you a better explanations in that case. Again, it's not one is better than the other. It really depends on what you are trying to sort of achieve out of it versus what you're not, right? So with that, I am going to sort of stop.
Thank you, Avi, so much. We have a couple of good questions, but I will give you a moment to, take a deep breath, take a glass of water, take a stretch. So we'll be back just shortly. With that, I just want to comment that this is absolutely amazing. Code generation competition looks like developers' life is made so much easier these days, and well, that's fantastic, and I hope all of you developers are eager to try completion generation, chatting with your code. If you want to try more, if you want to code more, I'm going to do the same as I do every time. I'm going to recommend you a Google for Startups Cloud program. I saw in a QA sessions that there were a lot of new people coming as well. So for those of you, just scan the code or go to our Google /cloud-program link. you can find out about the offer that we have for startups. Whether you're bootstrapped, backed by VC, AI startup, Web3 startup, we have offer for all of you for a lot of credits in cloud, in Google Cloud, so that you can build your solutions on us, with us. But apart from credits, there's much more access to experts, startup success managers, and more. Remember, Google for Startups Cloud program to build your own solutions using free credits from Google. Before we jump into QA, this is the third week, and this is Thursday. So like on every Thursday, I want just to ask you to grab your phone, scan this QR code right now, but don't fill in right now because we're gonna talk with Lavi just in a second. But please scan the code or visit our link, Google/GenAI-feedback W3. We would love your feedback to know what we can do better. And this is the compensation for our speakers to know how good they did and what can be a little bit better. Okay, with that, I think it's a time. We have a couple of minutes left. There were a lot of examples that Lavi was showing us. I loved them all, actually. And I think if I was a developer, it would be much easier for me to code and to create the documentation. Okay, so if we can get the Lavi back on screen.
Yes,
it's loading. Yes. So I'm gonna shoot you with a couple of those that I hope you can take. Zakaria is asking, for generating complex SQL queries, which code generation model would you recommend? Additionally, regarding BigQuery metadata, which elements would be beneficial to include in the context prompt, such as database schema or column table names?
That's a good question. In fact, we also have text to SQL version of the models, which we are currently experimenting. It's in private preview right now. So there's a new sort of model coming up very soon from Google Cloud, which is essentially built for the SQL. So it's like you put a text and you get the SQL, and it supports sort of different versions of SQL. So not just Google SQL, but it has support for different. So one is this, like just wait for it, and we're soon sort of going to launch that. The other part of your question is that as part of the metadata, what all can we sort of give, right? Like it shouldn't just be the table structure, and I would say, based on my experience, Zakaria, that just add everything that you can, because it is better to have more information rather than have short, because we also want to reduce hallucination, which is one of the big issues with many of the LLMs, which is if you do not provide them with all the instructions and the metadata, there are tendencies for it to sort of do hallucination. So I would say the bare minimum is the schema and everything related to the schema. But if you have extra sort of some data, feel free to sort of feed it to the prompt.
Okay, thank you. Prasad Varakur is asking about the customization of SQL. So how can I customize to generate a specific flavor of SQL instead of Google SQL, because he is using a different database?
Yeah, and I think I did answer this in the previous, which is the fact that we are going to come up with a text to SQL model, which is going to support many other sort of SQL flavors. So maybe your version is supported in that. If not, we do provide tuning. We will provide tuning for the text to SQL as well, and we already do provide the tuning for the models that you just saw, right? So as long as you have that data for your own flavor of SQL, and it's going to be not an easy data to sort of create, but if you, for all practical purposes, have that data, then theoretically you can sort of tune these and customize these model to address your SQL.
Okay. One of the questions that I saw, and is super interesting to me, because sometimes we are working in a very diverse groups of developers with different backgrounds, with different things they are used to. So Liz is asking, if I want to set a prompt template for all my engineers to follow, so we have a codified manner of using Cody and to reduce freeform and trial and error is there a way to make sure that if the structure is not followed, it will throw an error, for instance?
That's a very interesting question. And to sort of answer this, there is no error, sort of, there's no mechanism for the errors to come if you were to use Cody directly. As you can see, because that is a platform where you just send a prompt and it gives you something. So, for whatever reason, if you sort of add bullshit, it will sort of give you bullshit towards the end. So the way to address this, and you're thinking in a very right direction. You do not want people to do free form because you want them to be restricted to compliance, restricted to sort of standards in your organization. That layer is something that you would have to build before Koti. So you can almost sort of imagine that there's a layer that you need to build, and that layer is that which goes to the Kodi, not what the developers are writing. Unfortunately, we don't have anything as of now as an offering, but we are also going in the same direction. So once we make sure that our models are best and they're giving the best output, we're then going to sort of build these sort of templates out of it. The other quick thing is you can also use some of the open source frameworks. For example, LangChain sort of helps you do this very easily. So you use Cody models in LangChain, and then LangChain helps you define these templates in a very better way. So it's your choice. Either you define everything on your own, you build that layer on your own, or you ask Google to sort of help you build that layer as a PSO engagement or as a C engagement. Or third is you essentially use some kind of open source framework, which is like LangChain or something like that.
We are out of time, but I need to ask the last one, which is absolutely great for me. I know you might not know the answer, but I just want to voice out this one. Patrick Gomez is asking, could be a use case to translate an ancient software, for example, to help a company to migrate their legacy systems in Fortran, AS400, and things like that to the cloud. And she's thanking for the session. I'm really curious how our multimodal large language models can understand the ancient software.
It's a very complex answer. So the short answer is it's not easy. It's not like the way I was showing you the prompt, which is like you write something and it gives you something. All I can say is that there are some customers of us who are exploring exactly the same kind of translation, but it is not straightforward. We are sort of helping them build a data set. So we are going to them with their previous, let's say, last 20 years of translations that they have done manually through developers. We are getting that. We are converting them into proper data sets, and then we are trying to tune the models to understand that. So it's a slow process. It takes you need to have examples before. So if the question was, can I do this if I have zero examples, I would say maybe we are not there yet. But if you're like, no, I have like 20 years of translation my developers have done, then you're in a good shape. Like it still requires a lot of engineering.
You have something to train your model to like understand how to do this properly. Okay, Lavi, thank you so much for this. I remind to all of our participants, leave a feedback for Lavi, for us, for this week. Thank you once again so much. This was Lavi with Code Generation, Completion, and Chat. And all that is left to me is to invite you to the next week session. And we're going to go into the RAG architectures, including Vertex AI Search on Tuesday, same time. You know the drill. We're going to meet with Mandy and partly our AI ML specialist to talk about RAG architectures. So thank you so much for staying with us. Thank you for all the lovely questions. Please leave your feedback. Please check the notebook in your free time and join Google for Startups Cloud program if you need some credits for your startups. That was all. This was Timon, and see you next week. Bye.